Hi, my name is May Olatoye, and welcome to my final project for the Advanced Python for Data Science module, which I've called NanaBee, the Work from Home Helper. As we all know, the world went into a global lockdown order, and we embarked on this work from home global experiment that had several impacts, such as, for example, schools shutting down. This has meant that parents, for example, have had to take on a greater amount of responsibility and having a more multidimensional role within their homes as they simultaneously also work from home. There's also been a significant move towards digital learning, which has also increased the burden on parents having to facilitate this process within the home. So in the midst of all this chaos does present a potential opportunity. What if we could build a productivity tool that actually helps with scheduling of the children's activities, but actually removes the parent from the center of having to facilitate that? So for example, an application that could interact with children as young as 3-year-olds and actually give them simple voice commands to prep them to ensure they're ready for their next scheduled activity within the calendar day. We could also have this application potentially interface with other areas such as the school's calendar, extracurricular calendars, and other things like external tutors or external activities that the child may be involved in as well. Well, quite possibly there is a solution to this. We could build a scheduling app for the home that would incorporate these features and automate the process effectively so that we can also easily scale it for the future and add additional functionality that can also help with productivity generally across the board for scheduling of children's activities. So imagine you had something, for example, where if it was 5 minutes to a specific activity, this application would actually call out child 1, get ready, you have a math class in the next 5 minutes, you need to get ready and have a calculator ready, for example. Child 2, you have a French class coming up, you will need an iPad for this, etc., etc. Now, these sort of ideas or improvements might sound trivial to some people, but if you haven't actually been in the situation, you would possibly underestimate, if you're on a work call and your child is about to go into another activity, you probably don't want to drop off that call. It'd be amazing if you had some way of telling them how to prepare for that class and what they needed for that class and to be actually ready and seated for that class. So it can actually give some measure of improvement to facilitating that process by removing the parent from the center of all of that. Now, I've looked at building this utilizing the Apache Airflow framework. Obviously, there are other frameworks I could have utilized, such as Luigi, and some of the benefits that Airflow sort of allows is obviously being able to have its own local scheduler, which allows, if you're building and scaling the system, it allows you to do that more independently. But I think for me, I wanted to try something that was more challenging, different from what we'd learned, and also something that is lauded as the more sort of modern approach in industry as well, and see how that could fit into the framework of my solution. In terms of looking at the API side of things, primarily using Google Feeds and looking at what other interface feeds would need to utilize in terms of connecting to areas like the school, for example. I think one of the problems I had in the process is realizing the school's calendars did not come in default Google Feeds. It came as an image calendar. So we need to do additional work, some sort of OCR application to read that effectively. But for the purposes of this project, that would be out of scope. So we're primarily focusing on a Google Calendar API feed. And then also having some mechanism to actually group and view the activities daily and see what the participant will be doing on a given day, and actually laying the schedule and showing that to the parent via an email, for example, and giving them some sort of agenda reporting. From a data perspective, again, I won't be looking at collating all of that data and reporting for the scope of this. We'll just be focused on actually building the framework to actually alert the children to the timed activities. And then looking also from a notification perspective, there are various mechanisms that could be utilized, voice, email, push notifications. But I think, again, in being able to serve the children and being able to communicate with them effectively, I've focused primarily on the voice communication and executing that through Google Chromecast device. And then I've looked to deploy this to run on a Raspberry Pi. It can actually run on a normal computer, of course, that runs locally on my machine. But one of the reasons I like the idea of utilizing Raspberry Pi is as a scheduling application. It's something that we need to continuously run in the background daily. And what I like about the Raspberry Pi, it's a neat little computer. It can do a lot of things. It's very powerful, but it's also quite cost effective as well. And you can just have the application deployed on that and continuously run in the background. It can cost anything as low as $5, but the option that I've chosen to use for this project is a little bit more expensive, closer to the sort of $30 mark. But what's also great is we can actually also connect output devices for the voice communication to come through, such as the Chromecast connection, for example. Looking at the architecture or design of the application. So on the front end, I've used React.js, and then more specifically on the API backend side, I've got Flask that does the serving of the data from the backend, and then I built the backend essentially in Python, and then I've used a NoSQL database known as MongoDB, and as mentioned earlier, utilizing Airflow as the actual scheduler, and then taking in Google Calendar feeds, utilize various Google packages for that, and then having the text-to-speech notification, again, using the Google text-to-speech package, for example, to do that. Just quick overview of the types of data that looking to store as well. So we have the parent, and then that has a one-to-many relationship with the participant. So a parent can have multiple children, a child can have multiple schedules, and a schedule can have multiple tasks on it as well. So now let's take a dive into the back end and see what we've done from a Python perspective. So I created a couple of standalone executables that are invoked from the command line. So essentially, ETL process that's obtaining the feed from Google and then loading that into the database. So let's take a look at some of the modules here. So we're in the Google Calendar module, for example, and it will essentially take a name of a specific calendar that you want, and once it gets the name, or locate the pickle file to be used on the file system, get the credentials that you need to talk to Google, and then read in all the calendars and looks for the specific ID of the calendar that you requested, and then returns a list of events associated with that calendar and saves that to the database. Then we could also take a look very quickly at the save function, which is quite cool. So it's creating an MP3 file of the notification message, and then it saves the MP3 file to a location that will be accessible through a web server, then communicate to Google Chromecast, tell Google Chromecast to play the file via the web service, and then you'll actually hear the message of the activity that's about to take place. You can also have a look at this API module, which is quite simply just a Flask service with one endpoint called event. And this event service then reads the database and returns all the events in the database. And we can also have a look at one more element here on the front end. So we have front end is simply talking to the back end, using that event endpoint, and showing the list of upcoming events. So now let's look at Airflow and what we're doing under the hood here. So start off with one of the tags created. So we have a calendar feed, and it's a simple one task tag and runs the ETL job to extract the calendar from Google for a particular user. So in this case, this is the user, Myra, and this is the calendar. and it's doing this every 2 minutes essentially. And then from here, we also then create multiple notification tags. So we look into notification, and then we basically read all the events from the Events API, and then for each event, we create a DAG notification, and then within that DAG notification, it sort of waits for a particular start time, and then once it's reached, it will then run the particular task itself. So let's actually look at this on the front end with Airflow. So, so the simple one task calendar feed down, we can just have a look at that really quickly. You can see what we discussed where it looks for the specific user and then obtains the calendar as well. And then if we look at it for a notification example, so if we find a notification that hasn't actually been executed yet, so pick this one. Similarly, looking, so we do a manual trigger of it just so we can see it in action. Then if we just do a quick refresh and have a look at this speaking event. So again, this is a task. Replay is coming up next is what should now be triggered in the voice output. Replay is coming up next. A bit of a delay, but we got there eventually. So essentially, you can see how the various notification tags are generated and executed throughout the course of the day in terms of running to the schedule of the actual calendar itself. So have a look at the front end very briefly as well. So essentially we have a list of activities. These images are just dummies. It can be populated with whatever you like, but this is the schedule for the day for a given child, for example. So we can actually see how it links and reads from Google Calendar into the NanaBee system. So I'm going to populate for tomorrow an activity such as we're supposed to wait a 2-minute interval, as I previously mentioned, but I'm just going to force this to run faster and do that right now. And then going back to the front end and waiting to see that appear. I'll just refresh. And you can see the activity we added into the calendar from Google being read into the front end client, Hello Python. And then finally, just going to do a quick demo on the voice command output. You can modify it or customize it to a specific accent that you want to opt for. So user would configure it on the front end, but I'm just going to do a quick demo from the command line. So if you wanted a standard British accent, wake up and get ready in the morning coming up next, just run that. Wake up and get ready coming up next. You wanted something more Parisian, French-based. You wanted something more African or Nigerian to be specific. So in terms of the technologies that I've been able to utilize, first other aspects outside of Python as well, and it's been interesting trying to put that together and to work in harmony. And it's been a stretch challenge as well, working with other frameworks and toolkits, etc. So looking more at feature extensions in scope of the course itself. So currently, I've been able to utilize a number of different components and concepts that have been taught in the class, possibly 40% plus of that. And looking to the future, I wouldn't necessarily say that, you know, I would, for example, need to implement SQL for this specific application. It's already using a NoSQL database that has its own query language and functionality. But certainly, I think for something like visualization, for example, as I mentioned earlier, it would be useful once it starts to gather more data about the subjects and the participants to start to model behavior and responsiveness to activities and performance metrics, etc. A lot more once we have more of the solid basic data. So that would be cool to explore. And in the broader sense, I think there are other areas that could look to be extended. For example, linking it to more IoT devices. If the child had a smartwatch, maybe you could send push notifications to them directly through that, or even through an iPad. It seems every child has an iPad these days. And then also even there's security camera technology that allows you to detect when someone is in a room or not, for example. So if you had an activity such as maybe a piano lesson that's supposed to happen in a specific room and the child wasn't in that room, you could obviously detect that and then send a message to the child if that does happen, that you should be in that room right now because you have an activity in that room right now. So I think there's other ways you can expand and build for different scenarios that might be of interest in terms of tracking the child's activity and that they are conforming to the schedule as well. I also think there's scope for expanding the feeds that I take into the application. At the moment, I've just stopped using Google Calendar, but obviously different people your child would interface with, schools would deliver the calendars in different formats, for example. So maybe looking at some OCR functionality to actually read an image-based calendar, and just being able to interface with a wider repertoire of tutors or participants that would interact with your child as well, and then collating those feeds. And I think it'd be easiest implementing a Google Calendar and getting everyone to conform to that. But I think there is scope to also expand the way the feeds can be collected as well. And then, as I mentioned previously, I think the scope for doing more visualization reporting, getting that data, and perhaps also building some recommendations in. I think if you expanded this as a service past just this initial project, you might want to start connecting people to tutors if their performance was dropping in a particular area, for example, and there's things you can do there to expand functionality and usefulness as well. So that concludes my presentation. Thank you so much for taking the time to listen to it. If it's something you're interested in or you know someone that might find some value out of this, you can follow up as I continue to implement and complete this. I have a tinyurl.com at work from home NanaBee. You can follow, drop me a line, let me know what you think. It'd be really interesting to hear your thoughts as well. Thank you once again.